Today we're going to be talking about Modbus. Here's a brief agenda of what we're going to talk about. We're going to go over Modbus a little bit. There's really a lot of content on Modbus available. This presentation is more about Modbus applications and how to apply Modbus. So we'll go over how to add Modbus TCP to devices, how to extend an existing Modbus network, and then we're going to review a lot of the Modbus applications we've seen. And then we'll end it with just a list of some really good Modbus tools we've used. This is just an overview of Modbus. It's been around a long time. I think probably one of the most interesting points of Modbus is that led to its massive popularity was in the 70s and 80s, almost all the industrial automation protocols were proprietary, and there was no interoperability between any devices unless you bought them all from the same vendor. One of the reasons Modbus became so popular is Modicon put it out in the public domain pretty early. They made it an open standard when everybody else was proprietary. And I think that really drove Modbus to be as successful as it is today. And it's still used incredibly a lot, given that it's 40 years old. It's a simple protocol. It's master-slave. And I guess one thing I want to say is this is an older protocol, so some of the terminology is a bit older. I mean, we're not, when we refer to master-slave, we're only talking specifically about Modbus. But I guess on the serial side, just the way serial data operates, you can only have one device initiating communication, and the other devices have to respond to the initial request. So it does kind of fit the application, but it's older terminology. So it's a master-slave protocol. It can be run on the serial side, it can be run in Modbus RTU or Modbus ASCII modes. We're going to talk about those two modes. It can run on it can run on RS-232 or RS-485. And it also supports Modbus over TCP, which is a huge enhancement to the original Modbus spec. And they can seamlessly encapsulate the serial Modbus messages in TCP. And now Modbus is used across the entire internet and Ethernet networks. Here's some of the advantages of Modbus. It's super easy to implement. It's supported in just about every industrial automation software application. It has a Modbus driver. There is no, it's very low cost to implement. There's no conformance tests. There's no rules of use or certifications that are required to use Modbus. It's highly interoperable. That's probably one of its other biggest advantages. You can buy devices from multiple vendors that talk Modbus and they'll all work on the network. And most recently, we'll talk a lot more about this as well. Modbus can be extended or mapped to most all the newer automation protocols like Ethernet IP or Profinet. This is just a basic overview of how Modbus messages work. The master initiates the request with some data. The slave performs the action requested of it, and then it sends a response back to the master. It's not highly efficient, but it does work. The important thing to realize is the slave can never initiate a command all by itself. It only can respond to requests. There's really two modes that Modbus can be used in. It can be Modbus on the serial side, it's Modbus RTU or Modbus ASCII. RTU is by far the most common implementation that we see. The reason why is it's efficient, it uses binary encoding and CRC error checking, so it's pretty reliable. The RTU messages, however, are time sensitive. They're sent using, they're kind of like streamed on the serial line, and it watches for time gaps to determine the framing of the message. So if it sees a 3.5 character space time between characters, it assumes that the old message is ended and this is a new message. One of the main advantages of Modbus RTU is that since it uses the binary encoding, it's very compact and it gets better throughput over a serial network than Modbus ASCII. Modbus ASCII, on the other hand, is not binary encoded. It uses straight ASCII characters to represent the data. And it uses a slightly less effective error checking called LRC. It's not time sensitive. So what it has to do is use a start of message transmitter, which is a colon. And then at the end of the message, it uses a carriage return line feed to terminate the message. So it's way less lenient to, or it's way more tolerant of delays on the serial line. If it's a slower serial network, most likely you'll see Modbus ASCII being used. But the disadvantage of Modbus ASCII is there's twice as many characters for the same message as Modbus RTU. Modbus TCP was a huge enhancement. It came along later, but it allowed Modbus messages to be encapsulated in Modbus TCP packets and then sent across Ethernet networks. One of the biggest advantages of Modbus TCP is that you can have multiple clients polling or scanning multiple Modbus servers and slaves. In Modbus serial, RTU and ASCII, you were limited to one master. That's all you could have. But in Modbus TCP, it opened it up to much bigger network topologies. Probably the neatest thing they did with Modbus TCP to make it so seamless was they added this Modbus application protocol header, which goes right before a standard Modbus message in the TCP IP frame. This is a good example of what a Modbus TCP network would look like. You can have multiple, what's interesting is you can have multiple clients and you can have multiple servers, and they don't have to be PLCs. In this case, they could be generators, they could be sensors, or even a gateway. And off the gateway, it's very common application to see a gateway on Modbus TCP, and then on the other side of the gateway, you would have multiple slaves on a Modbus RTU network, and they can all send data seamlessly over Modbus TCP. This is just a good look at that Modbus application protocol header and how it takes a Modbus RTU message and puts it in Modbus TCP. So all right, now we're going to get more into the applications. We're going to start with how to add Modbus TCP to your product. Before we get exactly into that, I wanted to go over a little bit of, there's two methods with which a gateway would use when taking Modbus serial data to Modbus TCP. The first one is what we call bridge mode. And what's a little confusing is that while the functionality of bridge mode is common among a lot of gateways, what's confusing is the terminology is not. We use bridge mode, but you might see this as router mode, or you might see this as transparent gateway mode, or ATOP actually refers to this as Modbus ID routing. But the way this works is, and this probably is the main way that most gateways will take Modbus RTU data to Modbus TCP. The gateway, So the TCP, Modbus TCP client would send a request down Modbus TCP. The gateway would receive the Modbus TCP packet. It reformats it as an RTU packet and sends the packet to the Modbus serial device. So the gateway really here is a Modbus TCP server on one side, and then on the other side, it's a Modbus RTU master. So it takes the data from Modbus TCP, puts it into an RTU packet, and then sends it to the Modbus RTU slave devices. And you can have multiple, on a Modbus RTU network, you typically have several up to about 30, you can have up to about 32 Modbus slaves on that serial network. So you can have multiple slaves responding to a Modbus TCP client. One of the one thing that is notable about this mode is that it takes a little longer for the Modbus TCP client to get the response back, because it goes through the gateway. The gateway has to send the request to the slave, and then it takes a little time for that slave to respond back, and then that data to get back to the Modbus TCP client. The main advantage of bridge mode is that the slave device data is always the most current data. You'll see that compared to the next mode. The next mode is scanning mode, because in this mode, the gateway continuously sends Modbus RTU master commands to the slave devices and then stores those responses in internal memory. So now when the Modbus TCP client requests the Modbus data, it gets its answer immediately because the gateway looks in its internal memory to see what the latest data it had was and sends it back to the client. There's a lot of applications where the scanning mode is more appropriate than bridge mode. And we'll talk a little bit more about those on the next slide. Notable things about this is the Modbus TCP client will get a response right away. So here's some of the advantages and disadvantages of these two modes. With bridge mode, I mentioned you get the most current data, and there's less configuration required in bridge mode. So there is some configuration, but generally there's no need to have mapping data between the Modbus messages and the clients. Disadvantages would be unpredictable timing on the slave's host processor. It takes a little longer for Modbus TCP responses to get back to the client. And here's another disadvantage of bridge mode. If you look, you can have up to 32 slaves here, and you can have multiple masters. But as you have multiple masters requesting data from multiple slave devices, the serial port gets to be a fairly big bottleneck. So the response times get very long back to the clients. In some cases, the client communication will time out. So in scanning mode, the advantages are that it's very predictable timing on the slave's host processor. The TCP client gets immediate responses from the gateway. And this is probably one of its biggest advantages, is it allows gateways to get data between much faster networks like Ethernet IP or Profinet. And remember, I mentioned that Ethernet IP and Profinet have different packet structures. In those applications, you have to use a scanning mode and store the data in memory in the gateway to interface to the newer industrial automation protocols. It does have a slight disadvantage. There is some extra configuration or mapping required on the gateway. And there is an issue of timing here as well. The data can be older or stale depending on the cycle times with which it last read the slave data. So the data could be a little older than maybe you would get with bridge mode. And while that may not matter with temperature readings, because temperature moves fairly slowly, if you're talking about pressure or flow or some other variable, it could be important to the application. Okay, so now you understand the two different modes with which the gateway operates. Here's a very common application scenario that we can solve with a gateway. You have a Modbus RTU slave device, and your customers want you to add Modbus TCP. So in this case, we can use a Grid Connect gateway to connect to the Modbus RTU slave device and immediately start transmitting, allowing your device to communicate over a Modbus TCP network. Two of the big advantages as a product manufacturer with Modbus TCP is that you can have multiple clients and you're not limited to the distance of an RS-45 link. Now you can be miles away with an Ethernet network. This works in bridge mode, so a Modbus TCP client request would get immediately sent through the RTU network to the slave device, and then the client will wait for the response to come back. There's a less popular application, but kind of an interesting one. We see this maybe 10 to 20% of the time, where a customer will have a Modbus RTU master, but the master will only have a serial port. It won't have a network port. And they want to be able to take the Modbus RTU master and connect it to a Modbus TCP network. So again, we have a mode, a master attach mode in our gateway that allows you to connect directly to a Modbus RTU master. In this case, the gateway will send the master requests to Modbus TCP and wait for the responses to come back. And kind of a nice thing about this application as well is you can have multiple Modbus TCP clients, and you can have multiple TCP server devices on the net. Here's another interesting gateway solution that we sell. It's called the Unigate CL Gateway. It's a really powerful gateway in that it can support a lot of configuration options. It has a lot of topology. It has almost every topology option you can imagine that you'll ever run into with Modbus. It could be a Modbus RTU master or slave. It could be Modbus TCP. Any one of the interfaces can be any of those. It can operate in bridging or scanning mode. There's a lot of customization through a scripting language that they have. There's a universal script if you want to use straight functionality, but it can be customized with the script, and you can write the script, or actually Deutschmann will write the script for you. Has a lot of isolation for industrial networks, and it's DIN rail mountable. So it's a very powerful gateway for Modbus applications. This is an embedded gateway solution. So you may be, we always recommend that if you have a Modbus serial device and you want to take it to Modbus TCP or any other network, we always kind of recommend you start with a gateway, because the gateways are really easy to implement. They're very versatile, and you can be up and running on that protocol fairly quickly. But the disadvantage is that if you're scaling to any kind of volume, the gateways can be kind of expensive. So as your volumes grow, and the other thing probably about a gateway is they do require a separate power supply and some configuration that's in addition to the configuration maybe your product needs. So if your volume grows and you're looking for a little tighter integration and definitely a lower cost point, we have an embedded gateway solution we call the Grid 45. In this case, we're showing Grid 45 connected to a UART interface through a UART interface to the OEM's host processor. And in kind of the big advantage here is that in most cases, if your product's host processor already talks Modbus serial, we can add Modbus TCP with minimal to no changes to the host processor's firmware. So we can, it would require a PC board design change, but if the product already works through a gateway, then there's really not a lot of changes at all to the network configuration or any of the software that might be used in the application. The Grid 45 seamlessly takes Modbus data to Modbus TCP and back. This next section is really interesting because we see a lot of applications now where we extend a Modbus interface to a newer industrial automation protocol like Ethernet IP, Profinet, or BACnet. We actually even support MQTT to a cloud interface. And again, using Grid 45, you can, with an existing product that has a serial interface, maybe an Modbus RTU or ASCII interface, we can embed the Grid 45 in your product and take you to Ethernet IP, BACnet, Profinet, or even to the cloud via MQTT. Probably the biggest advantage here is it's fairly easy to integrate, and you don't have to be a protocol expert or as an OEM support multiple protocol developments. So if you have a product that's used in the industrial automation space and your customers you've got customers in the US telling you need Ethernet IP, and you've got European customers that are saying, hey, I need Profinet. That's a lot of engineering development, firmware development to integrate those protocols. With the Grid 45, we're going to support options for everyone that we have listed here. Here's another really good option for taking Modbus data to Ethernet IP. They even support CAN Open or EtherCAT, and it's the Unigate CL protocol converter. You can convert to these protocols. You can take a Modbus RTU device to any of these. With the universal script, you could do it without any programming required at all. If you have custom requirements or unique features that you need to support, there's a scripting language that, again, you can write or Deutschman can write it for you. But it's an industrial grade gateway. It's thin rail mountable, and you can take your Modbus RTU device and be on a modern network probably within days using this gateway. I guess, and here's, so we're going to talk a little bit more about some interesting Modbus applications that we've seen. Here's an interesting one where we've attached, customer had a Modbus RTU interface, and we took the data to Modbus TCP. But this manufacturer also sold a lot of generators to telecom companies that IT equipment in these cell tower. At every cell tower, there's usually a lot of equipment, and there's some IT equipment in there, and the telecom companies also use an older protocol called SNMP to manage the IT equipment. So when the generators showed up, they wanted to monitor the generators, and they're using SNMP, so their requirement was the gen sets needed to be able to respond to SNMP data requests from their SNMP manager. So we added SNMP to our gateway to allow one client to talk Modbus TCP to the gen set, as well as allow an SNMP manager to monitor the data through SNMP and the Net 45 gateway. And again, in this application, because the data packets of SNMP are completely different than the Modbus serial data, we had to implement a scanning. We had to use scanning mode here to get the data at SNMP. ATOP sells a really cool gateway called the 5501. It uses transparent mode. The interesting thing about this gateway is that it can take Modbus TCP data over Ethernet or Wi-Fi and communicate to a serial link to multiple Modbus serial devices via Modbus RTU or Modbus ASCII. Here's a couple more. Teltonica sells a cellular router with a Modbus interface. The cellular router combines cellular with Wi-Fi and wired Ethernet connectivity. So it can act as a Modbus TCP slave. It could be a Modbus TCP master, or it could be a Modbus RTU master. AKCP sells environmental monitoring sensors and gateways. And with this device, they can take Modbus data to one of their sensor probe gateways to bring the Modbus data to SNMP through the gateway. So again, just like the generator application, this allows the AKCP monitoring software to use SNMP to read the Modbus data and monitor whatever Modbus devices are attached. Rack Wireless sells a LoRaWAN Modbus converter called the Wiz node. LoRaWAN is a really useful protocol. It's license-free, but LoRa can go long distance, really popular in urban areas with farming equipment, utilities. But if you have a Modbus device, the LoRaWAN Wiz node bridge will let you take Modbus data over the LoRaWAN network. So in this case, it might be a substation meter, electric meter, or maybe a farm implement that needs to get the data back, the Modbus data back to a central server or client. And NetIO sells a 2-port power cable called the Power Cable 2PZ, and it's a PDU device that can control 2 power outputs. It could be LAN or Wi-Fi connected, and it's really a cool device if you need to monitor the power status or energy consumption of a TV screen or a multimedia player, or even IT devices like switches, routers, firewalls. And these can all be managed using Modbus TCP. It also has connectors to the cloud as well. And finally, here's a list of some really cool Modbus tools that we've seen and used. Top of the list is probably ModScan and ModSim from Wintech. These tools have been around a long, long time. ModScan allows you to simulate a Modbus serial network, or I had that wrong. ModScan allows you to be a Modbus serial master, and ModSim allows you to simulate Modbus slave devices. So very useful for testing a Modbus implementation. But we've also used Modbus Poll, which again is a Modbus serial master or Modbus slave. I think Modbus Poll also supports Modbus TCP master client connections. So does ModScan. ModScan supports serial and Modbus TCP. So there you have it. If you have any questions, we're going to open it up to live Q&A now. And I'm joined with Ed Landau, one of our principal software developers who's developed a lot of Modbus applications. Does anybody have any questions or challenges they want to talk about?
A general question on the Modbus. Thanks for the presentation, Gary. It was very helpful. Without a gateway, what is the maximum distance you can use for Modbus RTU?
If it's RS-485, the limitation is generally around 4,000 feet. Now, if that's a 485 string, then all 32 nodes have to be within that 4,000 feet. But if you use RS-422, you can have multiple Modbus slaves all 4,000 feet apart. Okay. So it depends. I guess the answer depends on what serial link you're using. I mean, obviously, if you go to Modbus TCP, now you're pretty much unlimited to how far apart you can be, given the you have routers and switches in there to carry the data. Did that answer your question?
Yes, for an RTU basic connection, I was thinking about the distance.
Gotcha. Okay.
Coming back to selecting which communication to use, do you recommend some type of connection, like instead of integrating into Profinet or between Profinet and Modbus? From your experience, what limitations and advantages do you come across?
Going between Modbus and Profinet?
Yes.
In general, Modbus is just a simple protocol, and going to Profinet, requires some mapping of Modbus registers into a Profinet packet, and there's a number of gateways that do that. There's no advantage or disadvantage to doing it. Sometimes if you have a Modbus device and it hasn't been given a Profinet interface, then you can use a gateway like we were talking about, external gateway, and you just set up the mapping from the Modbus protocol into Profinet packets. Now, Profinet requires what they call a GSD file, which is a file that is used by the PLC programmer to know, what the device is. And so you'd have to create that file for your gateway in order for the PLC programmer to be able to incorporate your Modbus device into their Profinet network. There could also be certifications required from Profinet, the PI organization. So there are some, let's say, hurdles if you don't go with a generic gateway. And by a generic gateway, it means that it already has a GSD file, and you have to conform your Modbus data into the how the GSD file is laid out. I don't know if that's clear or not, but if you move the gateway into your product, like we showed on one of the slides as an embedded gateway, then now you are making the device, if you're an OEM trying to create a Profinet device and you already have Modbus, you can create a Profinet device in that way. You still have to have your device certified and such. But
okay, it was not for an OEM, but just for an application where.
Just for an application, okay, yeah. So you would want the external gateway, and our sales team can walk you through that if you have questions about how to get that going.
Okay, so you did come across certifications for separate, if I use a separate gateway, for example. I'm just an engineer, but not fully experienced with this. That's why I attend this.
Yeah. No, that's why we're here. That's awesome. Yeah.
So there is a certification requirement if I buy a gateway.
There are gateways out there, and if you create your own GSD file, then technically you're supposed to be certified by a PI test lab. And there's one in North America, in Johnson City, Tennessee. There are ways that you don't necessarily have to do that if the gateway is already certified.
Thanks.
But you have to conform your Modbus device to it. So there are different ways we can do it.
All right. Thanks.
Okay. Well, thank you everybody for attending.